Okay, this is the worksheet over our ionic bonding notes. You are going to need your notes, of course, a periodic table, and an ion chart. If you don't have both of these, make sure you get these. Also, back in your notes, and most people miss it, back on the first page of this notes, it says to write your diatomic elements here on your ion chart. Okay, back on page, where is it? Right here. Molecules and compounds, page 1 of your notes. It says write these on your ion chart. All right, we need these. All right, it's called Brinkelhoff, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. These elements come in pairs, and that's why they're called diatomic, di meaning two. Okay, write those on there. We're going to need those, okay, at a future date. So I want you to have those on there. All right, let's look at this. We're going to use a periodic table here, metals or nonmetals. We should know this by now. We learned where to find metals versus nonmetals. What separates those? This stair-step line. So all you have to do is write metals or nonmetals here. Fill in the blanks below. How many aluminum atoms are in aluminum oxide? Okay, so here, let's discuss this real quick. The numbers up here, these little numbers, are called subscripts. The subscripts equal the number of atoms. So if it says how many aluminum atoms are there in Al2O3, aluminum oxide, there's a 2 out there, so there are 2 aluminum atoms. There's a total of 5 atoms, but only 2 of those are aluminum. And let's remember, if there's not a number there, there is an understood 1. Okay, give the symbols and number of valence electrons for these. If you did not write down your valence electrons on your periodic table back when you colored a periodic table, or you don't have a colored periodic table because you're starting in the third 6 weeks, I want you to write those on there. Let's recall real quick. Group 1 has 1 valence electron. Group 2 has 2 valence electron. Then we're going to skip our transition metals. Group 13 has 3 valence electrons. 4 has 4. Or 14 has 4. 15 has 5. 16, 6. 17, 7. 18, 8, except for helium only has 2 valence electrons. Okay, so you should be able to do this. Lewis dot diagrams, what are those? That is when you write down the element symbol with its number of valence electrons. Okay, so let's just pick one out here. Here's sulfur. I find sulfur, he's in what? Group 16. So I write his element symbol. So how many valence electrons does he have? Everything in group 16 has 6. So I'm going to put 6 valence electrons around him. And there is a specific order, but for our purposes, we don't care. As long as you've got your 6, they come in pairs. That's why I have 2 here, 2 here, and 1 on each side. All right, these valence electrons are what's involved in our ionic bonding, so we need to know how to set those up. Okay, so element symbol with the valence electrons. Okay, on the next page, it says give the oxidation numbers for these elements using ion notation. And here we have nitrogen. Where did that come from? Well, all I have to do, because I am very nice and I gave you an ion chart that has these, so I just need to locate my element. An ion is an element that has either gained or lost electrons. Okay, so it's gained or lost electrons. That's why it has a charge on it. So if you've lost electrons, you have a positive charge. If you've gained electrons, you have a negative charge. So over here, nitrogen's a nonmetal. Nonmetals gain electrons to become negative charges. So that's why it's a nitrogen 3-. You can also write nitrogen -3. Either way, I tend to write it like this. It just depends. Okay, so in the next part it says circle the correct answer regarding neutral atoms versus ions. Okay, so a neutral atom, what is neutral? That is when protons equal the number of electrons. Remember, protons are positive, electrons are negative. So if I have an equal number, it's a neutral atom because they cancel each other out, right? But if I have a different number of protons and electrons, when protons do not equal electrons, this is called an ion. That's what these are. Periodic table of ions when protons do not equal electrons. So when I say nitrogen -3, this says I've got 3 extra electrons right here than I do protons, because how many protons does nitrogen have? 7, because atomic number equals protons. And this is telling me I've got 3 extra electrons. How do I know it's electrons? Because they are negative. And I can only gain and lose electrons. I cannot gain and lose protons. So right here, I've got 3 extra electrons. All right? So if I've got 3 extra electrons, I've got 10 electrons. This is an ion. Protons do not equal electrons. Okay, name the element. How do I know the element? Because we know back here, we already know this. Protons equal the atomic number. So if I have 13 protons, I find atomic number 13. It's aluminum. Okay? Aluminum. All right? What's the charge on my aluminum? Well, let's hear. I've got 13 protons, so I got plus 13. I got 10 electrons and 10. So 13 minus 10 is what? Plus 3. All right, that's where the charge comes from. What's the charge on the aluminum? Plus 3. What does that mean? That means I've lost 3 electrons. I have 3 extra protons than I do electrons. That's what that means. Okay, so how many electrons are gained or lost? Well, right here, I've got an extra proton, so I lost 1 electron. These are electrons. I can't gain and lose protons. Right here, sulfur -2. What does that mean? That means I've gained 2 negative charges. I've gained 2 electrons. Okay, so looking at these, have I gained or lost electrons? Let me know if you have any questions.